Hello everyone, I'm Simon. I'm from the Bacalhau project. And I want to talk about some new features that we've been working on in the realm of federated data. So I want to start by talking about something that David said in the keynote yesterday morning. He said pretty much 100% or close to 100% of data has some limitations in its use, or like has requirements on how it is used, or access control requirements, or that sort of thing. Like there's actually very little data out there that is completely public and completely free to use. And I wanted to kind of explore that a little bit as a way of demonstrating why we're building what we're building. So this is a graphic from the Open Data Institute, which is a kind of data policy organization in the United Kingdom. And this is based on observation, I would say. So their model really is that data access is a spectrum. And what we tend to talk about in kind of technology circles is either the stuff on the far right or the stuff on the far left. So stuff on the far right, openly licensed, you can pretty much do what you want with it within the terms of the license. And stuff on the far left, completely closed, encrypted, private, shouldn't be seen by anyone, like very, very secure. But actually, the bulk of stuff exists kind of in the middle, where actually it's not completely closed, it's definitely not completely open, but access can be and should be granted for specific cases. I think the driving license example in that second column is a really good one. In the UK, we have a list of all the driving licenses. You can't get the list, you can't see the list, and nor should you. But the driving license agency that we have is able to give certain access to that list for specific reasons. So in the UK, if you want to rent a car, you have to prove that you have a valid driving license, and that's them giving access to that data out for a specific reason in a controlled way. So one of the other things that David said was 67% of data in an enterprise or in an organization is unused or underutilized. It's not really kind of exploited to its full kind of appropriate potential. And a lot of that is because most of that data exists in the middle of this spectrum where we don't have a very good story about how to make use of it. Why is that? Broadly, it's because when you have people who exist across different trust domains, sharing data might be something that they want to do mutually, but it's very difficult to do it because if you share data with someone, you have to trust them to uphold your standards. So it's really easy when the data is public or public access because the standards are very low, like there's not much protection you need to put around. But when the data does need protecting, you have to trust someone. So if you send them, a 300,000 record data set of all the customers that you've got, you have to trust them to not share it with anybody else that you don't want, not misuse it. Actually, there's a whole model around what that sort of trust looks like. This is a framework, or from a framework called 5 Safes, which is developed by the UK Data Service, part of the Office for National Statistics. And so it's really, this governs how they interact with researchers, but I think it actually is kind of relevant for all kinds of sharing of non-public data. And really, this is the sort of questions that people are asking themselves when they say, am I willing to share my data with this person? Am I willing to trust this person? It's ultimately about, is what they are planning to use the data for appropriate, like within my eyes, like do I think they're doing the right thing? Or do I think they even understand it well enough to not misuse it accidentally? Do I trust the people? Do I trust that they will uphold my standards? Do I know that they are not going to combine it with other data sets that might allow it to be de-anonymized? It only takes a couple of data points from different data sets linked together to be able to de-anonymize someone. Are they going to keep the data in a setting that is safe and will limit the use to what we've agreed? A lot of that is cybersecurity these days. And what are they going to do with the output? Presumably, they are going to want to share it onwards. I mean, again, this is about research, so where is the research output going to go? And is that result non-disclosive? So are they actually going to reveal more from the data set than I would want? And so you have to go through this whole exercise of like working out all this stuff and agreeing it just to share data. And actually, like, the people here are not necessarily in different organizations, they're just in different trust domains. So the example that I love talking about because it's so ridiculous is there's lots of data sharing that happens in the UK government that takes like 10 or 12 months of paperwork, governance effort, to allow data to be shared. And that's the UK government sharing data with the UK government. Not great. We could do better, I think, than that. But this is why. And unfortunately, even when you do all this stuff, it doesn't work. So this is a quote from another report by the ODI that was looking at data trusts. So data trusts are kind of the hot new take on data governance. If there is such a thing as sexy data governance, this is it. Essentially having legal control around a data set or data assets, putting them into trust, having trustees. A data trust is part of a much wider group of objects called like data institutions. But the point is that actually just having an agreement doesn't do anything for you. Like, if you manage to get someone to agree to treat the data that you want to give them or that they want to get from you in a way that is appropriate, if you don't have any enforcement power over what they are doing, that agreement is kind of meaningless. And I've specifically put in the part about Cambridge Analytica, which I think people probably haven't completely forgotten about yet, but if you don't remember the details, ultimately Cambridge Analytica were using data from Facebook that was meant to be used for research purposes. I think they were using it, if I remember, for like political canvassing and that sort of stuff. And Facebook's response was, oh, well, they misused the terms of the agreement. They weren't meant to be doing that, which I think kind of misses the point, because they did do that. And for every Cambridge Analytica that gets caught, they were caught by a fluke. There are, how many, 5, 10 more organizations doing similar things that ultimately are abusing the agreements through which they get this data, and they can't be caught because it's completely invisible. And the thing that sucks is there's no hard technical evidence here. There's no proof that they are doing the right thing or the wrong thing, so kind of unenforceable. My reckon is that compute over data should be the paradigm that provides some of that technical trust. And the reason is because it does that flip on the head of instead of sending the data out into the world and losing control and losing visibility, we're instead bringing the computation to the data and we can get that visibility. So we know what computation is going to be done. We know that if a project is safe or not. We can see the code that's going to run and we can make decisions based on that. The ability to do more computation can't be given out. Like, if I say yes to you doing computation, you can't then give that ability to somebody else unilaterally. All the inputs are known up front. Like, you have to give me anything else you want to combine with my data, and I can decide whether or not that combination is appropriate or not. Again, it's safe because the data isn't moving, and you can also make visible the outputs after the computation has been done, and you can check that what is coming out of the computation is appropriate. So the general principle being that if we keep control of the data, we don't move it around anymore, we can lower the required level of trust. Now we can start to allow people who we wouldn't want to have an agreement with previously to come and do things because it's so much easier to enforce that they are doing the right thing. So I have to trust them less, which means it's easier. And that's broadly the idea of what we're trying to enable with our new features in Bacalhau. So exciting news, Bacalhau can now compute across trust boundaries. That's broadly the feature that we've developed. What does that actually mean? I'll show you some diagrams of the sort of use cases that are now possible and kind of how it works. So if you're an organization A and you're a data owner, and you ultimately want people to come and use your data and make value and get value out of it, but you don't trust them as much as you trust people in your organization or in your trust domain, you can now submit computation in a way that is gated and pre-moderated. So person B on the right here will submit some computation and it will get stopped, and a whole suite of like algorithms, checkers, all sorts of things can run across it. Ultimately, it comes down to a human to decide whether or not the computation will run or not. Now, in the formulation of this feature that we have today, that's like primarily a human clicking yes or no, but I think you can probably imagine how it scales out to having more automation around whether that moderation happens or not, and only defaulting back to the human for either very exceptional cases or to define the policy up front of what is possible. So, like, do I want to run this specific container, or am I going to allow less certain things? It's all very configurable to be what the policy is. Once that has been approved, assuming it is approved, it goes off to the compute node that is attached to the sensitive data. The computation is done, the results come back, and again, there's another opportunity for gating. So the human or the algorithms, like a PII checker might be something that is involved at this stage, for example, can look at that data and say, okay, here is the size, here is the amount of entropy in this thing. Does this look good? Does it fit within our policy, yes or no? And again, the answer can be yes or no, that those results are safe to be shared back with the person who is of lower trust. So what sort of case are useful for this? Government is the one that I talked about, where you have maybe different departments trying to access data across trust boundaries. Another good one is research. So maybe where you have a university that is the custodian of a sensitive data set or a large data set, and they want to enable access to it by kind of citizen scientists or outside researchers with whom they don't have quite such a strong trust relationship. It also can be applied in cases where there is a more federated compute. So all these controls can be applied individually by individual data owners as part of a kind of wider computation across a federation. And again, where does that sort of thing fit in? Well, what's the example? So the example I think that I want to talk about is COVID stats. So I think when we first had COVID, we started collecting data from health organizations that exist in a devolved structure, in a federated structure like this, because there was no central reporting of COVID case numbers from a kind of federal location. It's all managed at the state level. And the way it happened in the US was that it actually took a volunteer group to go to all those different state health organizations, ring them up, send them emails, look at their websites on a daily basis to collect the stats. With something like this, it's kind of, you can allow that computation to happen across many, many different actors, all of whom are retaining control of their data and can switch that tap on or off at any time, but in a much more straightforward way. There's a similar thing with automotive, or, I mean, I guess actually any industry really, where maybe there is a body that wants to act on in the best interests of a group of competing individuals. So, like I've talked about automotive, but maybe there's a better example around like aeroplanes, where you've actually got, for the best interests of everyone, we need to have some federated computation across everybody's data, but done in a way that everybody retains control of what that is and can check that it's what they have signed up for when they agreed to take part in this. It also kind of unlocks what people are starting to call compute islands. So topic-specific compute in a kind of a public network or even in a private network. So this is less about the control of access to the data, but control of access to compute resource. So the three compute nodes on the left here don't have a human in the loop. Obviously, there is a human behind them somewhere. And they've signed up and said, actually, I want to donate my computing power, or I want to be part of a compute island that is going to operate on a specific type of workload. So, I mean, you only have to look around at the other people at this conference to know what that looks like. It looks like, you know, I want to do SETI at home. I want to do find a cure for cancer using my compute, and that's what I sign up for. And now we have the ability for that kind of citizen science or that kind of workload to be done and moderated by a trusted individual in the center who then is able to kind of delegate that out to various different nodes. So that's kind of what it's all for. Now I will attempt to do an exciting live demo where I show you what it looks like. This is what it looks like. So I've done the Blue Peter. I'm not going to write this command out, but I will explain roughly what it's doing. I am accessing, I'm running a Bacalhau node on my laptop. I'm running a network on my laptop, essentially. So this is a private network, and I'm asking it to access my company accounts and run a SQLite query over that. This isn't something that I would be happy to put in a public location or on a public network, and I certainly wouldn't be happy for anyone to come along and like just take a random look at my company accounts. But this is the sort of query that maybe I would be happy with. So I'm going to try and work out my expenses balance. So I'm going to submit this job to the Bacalhau node on my machine, and it has correctly detected that this is not the sort of thing that I want to run. I want to let anyone run and turn up, and it's now waiting for my approval. So I will give it approval. So this is our dashboard. I might make it a bit bigger. And it's got this job here. And you can see down here that we are waiting for moderation of that job. And I get access to all the stuff that Bacalhau has access to. So I can see here the query that is being run. I can dig deeper into the data if I want to. I can see that it's running from the input file that I gave it. And I can say, do I want to allow this job to be moderated? Yes. Calculating expenses is fine. And say yes. And that's approved the execution. And now that job has been kicked off, and the network is going to go and run it with the authorization that I've given. So it will go off and do that, and then at some point momentarily, that computation will finish, and it will say, okay, do you want to check the results before you release them? Because I think what we realize is that actually working out what, I've given you quite a simple example, working out what computation is actually going to do ahead of time is challenging. So actually a better way of doing things is to moderate the results. Right, so here we go. The computation is finished, the compute node has thrown away the container and has just got the results now, and it's now waiting for me to release those results. And I get a link to where those results are at the moment and some kind of basic stats about them. Again, if there was some automation involved in the back end that could provide me with things like, oh, what kind of data is this? Like, what are those files? And allow me to dig into them. That's something we're going to get to. But right now, we've got these basic stats. And I can see, actually, that before I moderate it, that also we've got things like what's come out on the standard out, which actually is only all that we're getting here, and that's the number. So I've got 1,500 of some currency in expenses due to me. Lucky me. So I will allow that to be done. And so I've moderated those two things, and now the job's finished, and I can download the results from the network onto my machine. So again, this is all about allowing people of lower trust to access things that otherwise they wouldn't be able to. And the way in which that happens is by having today a human, tomorrow more computers in the loop and able to say, yes, this is an appropriate job, or no, it is not. And appropriate is, of course, a very human concept, which is why we've started with the humans. So I think, in a nutshell, that is it. That's showing what we're doing. This feature is available now. You can now run, as Dave said yesterday, you can now run a private Bacalhau network yourself. You can run the dashboard and set up all the policies and configuration to allow you to moderate jobs in any of the ways that I've talked about in those previous slides. If you'd like some help or assistance with doing that, please come and talk to us on the Slack or on GitHub or in the Google group, and we'd be delighted to help you get this system working. Thanks very much. Am I going to have to run for my own microphone? Thank you. Oh, I'm not sure that's on, yeah.
What you showed, I remember last time Bacalhau was not allowing access to the network. Does that allow it now, or do you access just your local machine?
The broad answer is yes. So now, like, there's still a few kind of loose ends to tie up and actually get it all deployed onto the public network. But the plan very much is, yes, this is now the level of control that we need in order to give network access. So the ability to access the network today is done on a very slow-moving allow list. So there are like 5 or 6 domains that you can access, mainly from people who've come to us and said, oh, I want to run this type of workload on the Bacalhau public network. Will you put these domains on the allow list? And that's quite slow because it's essentially do a PR and then like release the software into the world. And that only happens like, once every 2 to 4 weeks or something. But now with this, yes, the idea is that we will be able to have jobs on the public network that are not generally applicable for all cases, where a human can come along and say, oh, this person looks like they want to access GitHub or to download something and compile it. I'm happy to allow that, or I'm happy to allow an entire class of jobs that look like that. So it should be a much tighter loop on allowing like a much more exotic variety of jobs. Yes.
So basically you kind of solved this security, because I understood this was done for the security reasons. So you kind of solve the security by kind of giving people like manual authorization layer, some sort of, for accessing internet from Bacalhau nodes.
Yeah, so I mean the security issue is broadly, we can't allow Bacalhau nodes to do anything that would A, be illegal, because ultimately we're responsible for what they do, B, violate the terms of service of our cloud provider, or C, degrade the network to the point where it's not usable by everybody else. I mean, ultimately, the public network right now it's a volunteer-provided compute network, so the people who are on it are not being incentivized to do that. We can't degrade the use of that network for other people. If we allowed arbitrary network access, we believe that would happen. As people come along and like do a bunch of Bitcoin mining, for example, in a tight loop where they're just consuming all the network resources, which is why we don't allow it. However, there are many, many use cases that don't fit that profile where we can say, oh, actually, yeah, you just want to like access some data from this specific API, or you want to download a package from like PyPy or whatever, that's fine. And we've always wanted to say yes to those things, but the risk of having to deal with all the bad stuff has always meant that it's been too difficult. Now it's much easier to do that, yeah.
I have a funny story and then a use case. I'm having flashbacks about 25 years ago with the National Science Foundation Decentralized Digital Library Project in grad school, and someone wrote a paper about using CGI bin to post both data and C code to any web server that would compile it. And clearly that became, it was a neat idea, but a terrible idea for many reasons. And it's great that we've come a long way and thought about some of these issues of trust and control. My wife works in public health with Harvard Medical School and other places, and they work with a network of over 100 hospitals. And they do public health interventions where code is operated in the end computing points that doctors interact with, and that data is stored. And then it gets aggregated now to like one place at Harvard Medical School, and there's like, trust us, we'll keep it private, right? And essentially they need to run, R and SAS and other statistical analysis. So this model would be great in keeping that data where it's captured, because they don't actually need the raw data, and there's still a lot of risk in their model today. So I think, yeah, really makes sense, and there's a number of human rights use cases we're looking at as well. So
that's great. I'd love to come talk to you about that. I mean, I think, as ever, everything we're doing today in the 2020s, they already did it in the 60s. And what we're doing is doing it in, a more modern way. But I think what we're trying to do with Bacalhau is make some of that stuff more commodity so that you can apply it in more cases. Because having worked in UK government, like obviously you can move data around and do it all. It's just very, very expensive and very custom every single time. And it has, unless you build the infrastructure, exactly the sort of safety problems that you mentioned. So yeah, that's exactly the sort of use case I think that we're thinking of, where the data needs to stay put. A part of this talk that we didn't have time to get to is like federated machine learning, where you've got a bunch of data that very much needs to stay where it is, and you want to build a machine learning model over that data. How do you do that? Well, either you move all the data bad, or you do it in a way like this, where you can send the training to the data, and then you send the weights back. And that's something that we've got a kind of live demo for, but I didn't have time to show it today. So yeah, very much that model is what we're going for here. Cool. Thank you very much, everyone.